It's always nice when technology works. Okay, today is a very, very fast-paced lecture. It's what I take about, at least an entire week in pre-calculus to cover. And we're covering it in something less than 50 minutes today. We have 3 sets of formulas here, and we're talking about graphing conic sections. And they're called conic sections because you can get them from different ways of slicing a cone, hence the term conic. The parabola that we're looking at is going to be the first equation that we're talking about. And the definition for the parabola is a set of all points x, y that are equidistant from a fixed line called the directrix and a fixed point called the focus, not on the directrix. The standard form of the equation of a parabola with a vertex hk, if you have the vertical opening, it's x minus h squared equals 4p y minus k. The focus is h, k plus p. The directrix is k minus p, y equals k minus p. If it's horizontal, you have y minus k squared equals 4p x minus h. Your focus is h plus p comma k. The directrix is x equals h minus p. The eccentricity of a parabola is defined to be 1. Just the eccentricity tells you how bent your parabola is. In this case, parabolas are always defined to have an eccentricity 1. Ellipses and hyperbolas have different eccentricities. So let's look at some examples here. Find the vertex, focus, and directrix of the parabola. Sketch its graph. To be able to do this, I have to put it into standard form. Remember completing the square? Yeah, that was met with enthusiasm. What I'm going to do is I'm going to take the 4y and the 4 over to the other side. Keep all the squared terms on one side. So x squared plus 4x is equal to minus 4y plus 4. Half of our middle term is going to be 2. And then I have to square it and add and subtract that value. I'm going to factor the first 3 terms, so that gives me an x plus 2 squared minus 4 is equal to minus 4y plus 4. I'm going to add that 4 over to the other side, and I get x plus 2 squared is equal to minus 4y plus 8. Factor out a minus 4, so we have the y term positive, and I have x plus 2 squared is equal to minus 4y minus 2. And now I'm ready to identify all the parts. Remember, the form is x minus h squared is equal to 4p y minus k. So in this case, h comma k is going to be, think about the opposite sign. Right here, we have a plus 2. I want it to be minus h, so it's going to be the opposite sign of plus 2. So h is going to be negative 2, and k is going to be a positive 2. Just think opposite sign. So hk is going to be negative 2, 2. Now looking at your formulas here, is this a horizontally opening parabola or vertically opening? Vertical opening. So how do I find the focus using their formula? It's going to be hk plus p, right? So I have to identify p. P comes from this part, that minus 4. This minus 4 right here has to be equal to 4p, and that's what I'm going to do to solve it. Minus 4 equals to 4p. What does that tell you p is equal to? Negative 1. So the focus is going to be negative 2 for h, k is 2, and then add your negative 1. So it's negative 2, 1. And then the directrix. It's going to be y equals k minus p. K is going to be our 2. minus a minus 1. So y equals to 3. And then it said sketch the graph. I found the vertex, I found the focus. Now let's, and the directrix, let's sketch the graph. What I'm going to do is just sketch the focus, the vertex, and the directrix and approximate the sketch of the graph. So my vertex was negative 2, 2. My focus was negative 2, 1. And the directrix was at 3. Your parabola always opens around its focus. So something like that. And that's our graph. I don't want you to be worried about where it intersects the x or y axis or anything like that. You just sketch the graph based off of the directrix, the vertex, and the focus. Give a representation of it. Any questions on that? No? We good? Okay. Find the equation of the parabola with vertex 5, 4 and focus 3, 4. So when it says find the equation, the easiest thing to do is to graph the information they give you. They tell you the vertex is at 5, 4. So there's a vertex. And it says the focus is at 3, 4. It has to open around the focus. So is this a horizontally opening or vertically opening? Horizontal. Horizontal means I'm going to have y minus k squared is equal to 4p x minus h. Now, is it opening left or right? Left. Left tells you that p is negative. Down and left is negative for p, up and right is positive for p, so I know p is going to be negative. And I also know that p is the distance from the vertex to the focus. So what is that distance? Two. Except it's opening left, so I use a negative 2. What is h and k? That comes from our vertex. H is 5, k is 4. I can plug it in. So y minus 4 squared is equal to 4 times a negative 2, x minus 5. What is 4 times a negative 2? Negative 8. There's our equation in student form. Question? Why is it negative? Because it's opening to the left. Whenever it opens to the left or opens down, p is negative. P is the direct distance. Any other questions? Can we do that on our homework? You have a couple of questions like that on the homework. Hopefully. Okay, find the equation of the parabola with vertex 0, 5 and directrix y equals minus 3. Here again, start by graphing it. So 0, 5 is right here, and that's my vertex. And my directrix is y equals a negative 3 down there. Halfway in between the focus, well, sorry, I won't say it that way. The distance from the vertex to the directrix is also going to be p. That means that up above on the opposite side of the directrix should be the focus. Is this going to open up or down? Up. It has to open away from the directrix. So it opens up, and I can find P. P is the distance from the vertex to the directrix. Is P positive or negative in this case? Positive, because it opens up. So let's find what P is. What is P going to be? What is that distance from -3 up to 5? 8. And I know the vertex, H is 0, K is 5. It opens up, so I know this is x minus h squared equals 4p y minus k. So plug it in, I have x minus 0 squared equals 4 times 8 y minus 5. Or x squared equals 32 y minus 5. There's our answer. We like the ones that say find the equation of. Those don't have much work. But when they give you a simple general form equation and ask you to put in standard form, you know you have to be completing the square. That's going to take a fair amount of work. Okay, one thing you need to know about parabolas, only one term is squared. You can identify what these equations are going to be before you even put it into standard form. If you only have an x squared term or you only have a y squared term, you know it's going to be a parabola. Okay? You're going to have a homework question. It's going to give you a whole bunch of them and tell you identify them. Are they parabolas, ellipses, or hyperbolas, or a circle? And this is how you tell. Okay, let's carry on. Let's look at the definition of an ellipse. An ellipse is a set of all points x, y, the sum of whose distances from two distinct fixed points called the foci is constant. The line through the foci intersects the ellipse at 2 points called the vertices. The chord joining the vertices is called the major axis. Its midpoint is the center of the ellipse. The chord perpendicular to the major axis at the center is called the minor axis. And the standard form of the standard form of the lengths 2a and 2b, where a is greater than b, is, if you have a horizontal major axis, x minus h squared over a squared, y minus k squared over b squared equals 1. Everything is going to always be equal to 1 for ellipses and hyperbolas. This a squared is always the biggest value. It might appear second in your equation, but you're going to make a squared be the biggest value in the denominator. B squared is the smallest value. A vertical opening axis has the bigger value under y. Horizontal opening has a bigger value under x. The foci lie on the major axis, c units from the center. C is equal to a squared minus b squared, and the eccentricity is c over a. For ellipses, the eccentricity is between 0 and 1. If E is close to 0, you have something almost circular in nature. If E is close to 1, you have a very squished and elongated ellipse. A lot of equations to know. Let me simplify this for you. We'll do an example. Find the center, vertices, eccentricity, and foci of the ellipse, and then graph the ellipse. Notice I put this in general form again. Notice I have two squared terms here and a plus in between the two squared terms. They're both the same sign. That tells me this is an ellipse. It is not a circle because I have a 4 here and a 1 here. I don't have the same leading coefficients on my squared terms. This is an ellipse. I'm going to group the x terms together and the y terms together. So we have 4x squared minus 8x plus y squared plus 4y. Oh, I wrote a 48. Plus 4y equals 8. And I took the 8 over to the other side. Well, notice here you have a leading coefficient of 4, so factor that 4 out. And what is half of 2? Half of 2. This is not a trick question. 2 over 2 equals 1. So add 1 squared, subtract 1 squared. Notice something very important here. I kept everything inside these parentheses right here. Because when you bring this minus 1 squared out, you have to multiply it by that 4 right there. So keep it all in the parentheses together. And let's do the y's. There's nothing to factor out, for no leading coefficient. So 4 over 2 is equal to what? 2. So I'm going to add a 2 squared and subtract a 2 squared. So what I get is 4 times x squared minus 2x plus 1 plus 4 times a minus 1. And then y squared plus 4y plus 4 plus that minus 2 squared, which is our minus 4. I'm going to write that as a minus 4. How do you factor x squared minus 2x plus 1? X minus 1 squared, and then 4 times a minus 1, negative 4. And then how do you factor y squared plus 4y plus 4? Y plus 2 squared, and then our minus 4 equals 8. Combine our minus 4's together, and what do you get? Negative 8. I'm going to put that last. And then we're going to add that 8 to the other side. And we get 4 times x minus 1 squared plus y plus 2 squared is equal to, what's 8 plus 8? 16. Now I have to set it all equal to 1. So what we do is we divide everything by that 16. When I do that, I get a 1 on that side. And this 4 cancels with the 16, leaving you a 4. So my final form is going to be, I'm going to write the y term first because it has a bigger power, a bigger number in the denominator, and the x term second. So does this open vertically or horizontally? Vertically, a squared is 16. B squared is 4. Let's go ahead and find its center. The center comes from what's inside our parentheses. So we're going to have 1, negative 2 for the center there. When it says the vertices, it's talking about the vertices on the major axis. According to your formula sheet, what do we add? The vertices is going to be what? K plus or minus A. So this is going to be 1, negative 2, plus or minus. If A squared is 16, what is A? 4. So this is 1. Minus 2 plus 4 is 2. Minus 2 minus 4 is a negative 6. There are the vertices. Let's see. Foci. Foci say this is HK plus or minus what? C. So let's calculate C. I know C squared is equal to A squared minus B squared, which is 16 minus 4, which is 12. So C is the square root of 12. We're not going to calculate the square root of 12. We're just going to write it down. So write it minus 2 plus or minus the square root of 12. And that's all we're going to do. We're not going to evaluate that. And then the eccentricity E, which is C over A, is going to be the square root of 12 over 4. Now, all of that, question?
Did you see this at a vertical major axis?
Yes,
okay.
This one's vertical. Because the biggest value is under Y.
Yes, that's what I thought.
Yes. Now watch carefully. I'm going to show you how to graph these really, really easily. And on the test for chapter 10, I'm going to ask you to graph these. I'm not going to ask you for the center vertices, foci, and eccentricity. I'm simply going to ask you to graph them. You can graph these without knowing any of those values. Let me show you how. These are very, very easy to graph. The first thing, you go down and you look at your equation right here. And you just graph your center, which you know is going to be 1 and -2. You look under y, you have 16. So in the y direction, go up and down the square root of 16. What is the square root of 16? 4. So let's go up and down 4. 1, 2, 3, 4. That takes you up to 2. 1, 2, 3, 4. And down to -6. Go left and right from your center, the square root of the amount under x. What's the value under x? 4. Take the square root of that. 2. Go left and right 2. So you get it right here and right here. And then you're just drawing your ellipse through those points. All you have to do is find the center, go up and down from the center, the square root of the amount under y, go left and right, the square root of the amount under x. Join it with an ellipse. These can't be easier to graph. We made you graph a lot harder things in pre-calculus. Okay? Not hard to graph. That's all I really want you to know how to do, is to graph it. I have to show you the rest of it because I can't separate on WebAssign the graphing from the rest of it. It puts it all in one problem. So you have to be able to do the rest of it for WebAssign. I really don't care about the rest of it. I want you to know how to graph these. What is a basic shape? The reason for that is we're going to turn around and graph all of these in polar coordinates. And they're not hard to graph in polar coordinates, but you need to know what their shapes are. Any questions on setting this up and graphing it? Okay? Let's find an equation. It says find the equation of the ellipse with vertices 3, 1, 3, 9, and minor axis of length 6. So let's graph it. It says vertices were at 3, 1, and 3, 9. So I know that it has to be opening vertically. The farthest away are the vertices. And it says a minor axis has a length of 6. Remember, B gives you your minor axis. So 2b equals to 6. What does b equal to then? 3. And the 2a is going to be the major axis. Major axis is the distance from 3, 1 to 3, 9. What is that distance from 3, 1 to 3, 9? 8. So if 2a equals to 8, what is a equal to? 4. And now the center is a midpoint of the vertices. So the midpoint is going to be 3 and then 1 plus 9 over 2, which is 5. Just plug it into the equation. This is vertically opening, so the biggest value goes under y. I'm going to have x minus 3 squared over b squared plus y minus 5 squared over a squared is equal to 1. B is 3, so what is b squared? 9. A is 4, so what is a squared? There's your equation. A lot easier to find the equations. Any questions on that? Feeling a bit overwhelmed yet? All of it and yeah. Okay? I saw this mistake and I went to fix it and I forgot to. hyperbolas. Please look carefully on your sheets and tell me what is the difference between a hyperbola and a parabola in its basic equation. So under the horizontal major axis and vertical major axis, what is the difference, the key difference in this equation right here? Yeah, the ellipse has a plus there, right? Hyperbola has a minus there. You recognize hyperbolas because there's a difference in sign between the squared terms. So that's going to tell you it's a hyperbola. The vertices foci both look the same. They have something here that they're going to call asymptotes. I'm going to show you about those when we graph it. But don't worry too much about it other than be very careful which form of the asymptote you choose, because one of them is B over A and one of them is A over B. So you have to be very careful about which form you choose. The other thing on this right here is that C squared equals A squared plus B squared. We recognize that as our Pythagorean theorem. For hyperbolas, the eccentricity E is going to be bigger than 1. That's important to us later on when we start graphing these in polar coordinates. If E is close to 1, the branches of the hyperbola are much more curved. If E is far away from 1, much bigger than 1, then the branches are nearly flat and there's not much curve to them. Find the center foci and vertices of the hyperbola. Use the asymptotes to sketch the graph of the hyperbola. Here again, complete the square. And that's not going to work. So group the x terms together. I have x squared plus 2x. Group the y terms together. And take the 81 over to the other side. What is half of 2? 1. So we have x squared plus 2x plus 1 squared minus 1 squared. Factor out the 9. And you have y squared minus 6y. And what is half of 6? 3. So plus 3 squared minus 3 squared. Factor the first 3 terms. You have x plus 1 squared minus 1 minus 9, y minus 3 squared, and plus or minus 9 times a minus 9, and that second minus 9 comes from right there. Now combine your minus 1 and your minus 9 times a minus 9 is a positive 81. So what is 81 minus 1? 80. So let's subtract our 80 over to the other side. And we get x plus 1 squared minus 9, y minus 3 squared is equal to 1. So I'm going to say that these are divisible by 1 then, because I have to have them as a fraction. Unfortunately, I'm not allowed to have something up in the numerator of my fraction other than the x minus something squared or y minus something squared. So watch carefully. I'm going to take that 9 down into the denominator. And it becomes a 1 over 9. You guys see that? That becomes a 1 over 9. Now, on hyperbolas, a is always the first value. It's not the biggest value. It's the value under the positive term. So if the 1 over 9 had been over here under x, that would still be a. A is the first term for hyperbolas. So a squared here is going to be 1. B squared is equal to 1 over 9. And c squared is equal to a squared plus b squared, which is 1 plus 1 over 9. What is that? 10 over 9. Okay? just added fractions. So then that tells me A equals to 1, B is equal to 1/3, and C is equal to the square root of 10 over 3. Now let's go ahead and write our center. Our center we get just the same way. It's going to be the opposite sign of what you see inside the parentheses. So we have -1, comma, 3. Oh, I wanted to do vertices first and then foci, because I think that's the order that I have it on the paper. So is this horizontally or vertically opening? Horizontal. A is the big value. I'm sorry, the first value is under X. It's a horizontal opening parabola. In that case, for the horizontal opening parabola, the vertices are H plus or minus A, comma, K, which is our H is -1, A is 1, and K was 3. So -1 plus 1 is 0, and then -1 minus 1 is a -2. So there's the vertices. The foci is H plus or minus C, comma, K, which is going to be -1 plus or minus square root 10 over 3, comma, 3. And we don't do any more simplifying for that. We just write that down. They say to find the eccentricity, which is C over A. So square root of 10 over 3 divided by 1. Square root of 10 over 3, that is bigger than 1. Square root of 10 is bigger than 3. And now the most important part is how to graph it. Oh, it says use the asymptotes. Okay, it didn't ask me to write the asymptotes. It says use the asymptotes to sketch the graph. First things first, find your center. Our center was -1, 3. Just like we did with ellipses, we're going to go left and right the square root of the amount under X. The amount under X is 1, so I'm going to go left and right the square root of 1, which is 1. So that means I go to here and here. And then you go up and down the square root of the amount under Y. So that would be up and down 1/3. So small amounts. And now, instead of joining with an ellipse like we did before, we're going to draw a rectangle through these points so that each of these dots is the middle of the side. Okay, I'm going to draw this in a different color. Each of those dots is the middle of a side. Let me try that again. Okay, we have our rectangle drawn, and now we draw the diagonals with a dash. The line, the diagonals of these rectangles is the asymptotes. It says use the asymptotes to sketch it. And now you know it's horizontal because the X term is first, so we're going to draw our hyperbolas horizontally through that. And the hyperbolas approach the asymptotes. Oh, that didn't work so well. Let me try that one again. There's our graph. Mine's a little crooked. Sorry about that. Any questions on that? I really don't care about whether you can write the vertices, foci, eccentricity down as much as whether you can graph it. I'm going to be asking you to graph these on the test. No, this is on the test on chapter 10. Okay, so let's do an example and then we'll be doing our classwork. Find an equation of the hyperbola. The vertices are plus and minus 1, 0. So here's -1, here's 1. Those are the vertices. And the asymptotes are equal to plus or minus 5x. So here's the asymptotes. So I know it has to be opening like this. Is that horizontal or vertical? Horizontal. I know that the vertices are minus 1, 1. The center is in the middle of the vertices, so where is the center? 0, 0. Center is the midpoint of the vertices, so it's at 0, 0. And then it's horizontal, so I use the horizontal equation for the asymptotes, and we get y equals to k plus or minus b over a x minus h. Now I know h and k are both 0 because those come from the center. So that gives me the equation y is equal to plus or minus b over a times x. Comparing that with the equation they gave us, that means plus or minus b over a is equal to plus or minus 5 over 1. That says b is equal to 5, a is equal to 1. I am ready to write down my equation. It's horizontals, so the a value goes underneath the x. So I have x minus 0 squared over 1 squared minus y minus 0 squared over 5 squared is equal to 1. Or x squared over 1 minus y squared over 25 is equal to 1. And there's our equation. The equations for these are very easy to write down. Any questions on that? Yeah. You have to, whether your vertices are above each other, that would be vertical, or across from each other, that's horizontal. So that's the only way to tell. Any other questions? Okay. You have some classwork problems to look at. Let me stop the recorder.